Saul, in really trying to understand what it's all about, and I study science, one of the presumptions that we have to make as scientists is that the laws of physics, the basic laws we deal with, are relatively constant and maybe totally constant. But this difference between absolutely, certainly, and forever constant, here the same as across the universe, here the same as across time, is different than being relatively or absolutely. This question of, can the laws of physics have some mobility to it, some flexibility?
Yeah.
A lot of theories around this. What you've been able to do in your cosmological work, looking out at the universe, is through perhaps a 10 billion year period of time, from recent times to 10 billion years ago, being able to look at physical law. Can you elucidate this question? Are physical laws constant?
I mean, it's interesting because to some extent, it's almost what you mean by physical law to say it's constant. And this is in the biggest sense of the term, because if you imagine that things are changing on you, then any measurement you did today would be relevant to another measurement you did, a week earlier or a year, before that. So in some grand sense, you have to assume that nobody's playing tricks with you and changing all the laws, behind your back while you're trying to study them. I think that would be you think that would be an impossible world to understand. Now, but when people talk about changes in physical laws, I think what they usually mean is saying a little more specific than that. What they mean is that within the understanding that there's some fundamentals that are always the same, there's certain things that look like physical laws to us today, which could change their value a little bit. They a slightly different amount of this or amount of that,
yes.
And that those would be very hard for us to discover because you couldn't do any local experiments using things on Earth. You'd have to find something way back in time and see that it was behaving a little bit differently than it would have been predicted if you used the same exact form of the laws that you have and values for laws today.
Right.
Perfectly possible. I think in the big picture, you'd end up having to explain how that slight change happened. And that is a super law. There would still have to be a bigger law that
Right.
stays constant, that shows how that evolves, or else you're not doing the kind of science that we're trying to do.
Yeah, or some would say that super law might be a random law, but that's a
true,
law in
true.
itself.
That's right. It could certainly things could wander, and then you have to show how that works. I mean, how that wanders.
But this question itself, to address that issue, whether some of the constants of physics could have very slight variations or absolutely none, is a very fundamental one. It has a lot of implications for understanding.
Absolutely, and in particular, the kinds of measurements that we were doing. You mentioned the study of, in our case, the expansion of the universe, all the distances between the universe getting larger over 10 billion years. We had thought that it would be mostly governed by a single aspect of physics that we knew about, which would be gravity. And of course, what we discovered not that long ago now is that apparently there's an extra element to the story, which wasn't in our original picture. So in that sense, we've seen a bit of the physics changing over time.
That is not necessarily a physical law changing, it's a physical effect changing, because there may be more than one physical law operating.
Exactly, and maybe more than one
different character,
or maybe more than one component, entity out there that's being acted on by those physical laws.
Sure, and we might see one result that's the combination of multiple things working in different ways, in different time frames, and different scales, that you only see the one result, but only by plotting a number of data points over time can you begin to try to tease out the differences.
Precisely. And so that's, I think that's completely consonant with what we've seen.
Okay, so we know there's extra things going on. That we know for sure, because you can trace differences in the expansion rate of the universe over time.
Precisely, that we think are caused by these different effects taking a bigger or smaller role over time.
Okay, so again, there's different laws that are competing together in different frameworks to produce different results.
And the only thing that I might quibble with would be that we don't yet know, in some sense, whether to call this a change in physical law, or whether we just say, nope, it's the same physical laws that we've been dealing with, but maybe just an extra component, an extra entity that is acted on or by with these physical laws.
Well, now let's go to the next question in terms of, could there be changes in one of the physical laws, in one of the constants. And people have talked about
Yes.
looking back in the universe, the so-called fine structure constant,
Yes.
which is one way. Has been controversy about that. Are there any hints that you feel comfortable with in terms of looking at an individual law that it might be changing, or pretty rock solid?
I mean, I love these experiments, these observational programs, because I mean, I think it would just be amazing if we saw clear evidence that something like the fine structure constant, which is one of these,
Which is
which is one of the key ratios that shows up in physics, of charge to mass and things like that in the makeup of the universe. If you could catch one of those in the act of changing, I think that would be great. Now, I would say so far the experiments that are out there, some of them were rather intriguing because they looked like they might be showing hints of it, but right at this point, I'd say there's consensus of the community is that we don't have any evidence that we have to really grapple with yet of that kind. That we have to keep exploring, and I think we have to keep inventing new experiments and observations to look for that. But so far, there's nothing that we have on our plate today where we'd say, we have seen some fundamental constant of nature that we thought was always the same, changing. And that would be wonderful if we ever found such a thing.
wonderful in what sense?
Well, there's nothing that a scientist, I think, loves more than a great new mystery and a great new clue to something that we haven't picked up in our physics before. And that would be an example of something that would say, wow, look right there. If we can explain that, maybe we'll be able to explain much, much more.
So every time you have a mystery like that, which is a shocking mystery, it potentially opens up a way, if you're going to explain that explanation is going to deal with a lot of other things that you hadn't expected.
Precisely. I mean, it was my sense is that the real progress in the sorts of science that I've been watching always comes from the surprises and the things that make no sense. Usually the stuff that just confirms what you already knew helps you consolidate where you are, but it's these surprises that you're really always looking for to give you a key into the next step.
What's your expectation? What's your best guess? Do you think there will be some physical law, individual single laws whose constant may change over vast amounts of time?
Boy, if I had to make a guess, I would, at this moment in time, say it would really surprise me if any of the really fundamental physics constants changed when we look at them. On the other hand, we were surprised when the universe was accelerating. And so I don't know whether that will be the next surprise or some other thing will be the next surprise, but I would expect surprises.
The one thing you won't be surprised by is surprise.
Precisely. I think if we never had a surprise, then I'd be surprised.